Hey guys, get started on these problems right here, just so you have something to work with while I get everything set up, and I'll be right back. All right, so if we look at number 30, the first thing we have to do is gather all of the x terms on one side of the equation. It really could be either side, but most of us are most comfortable reading from left to right with these inequalities. So we'll gather x on the left side. So negative 4x minus 5x is negative 9x plus 10 greater than or equal to 55. Then you subtract 10 from both sides. Oh, why did I write 11? That was weird. I said 10 and then I wrote 11. Okay. So we have negative 9x greater than or equal to negative, or pardon me, 45. 55 minus 10 would be positive 45. And finally, to get the x by itself, we divide both sides by negative 9. Now, when I do this, I am going to trigger one of our rules about inequalities, which is when you multiply or divide by a negative number, you have to flip the inequality symbol. So it's going to flip from greater than or equal to less than or equal to. And then we have negative 9. Okay, so notice that the question isn't what is the inequality, right? It says what is the solution set of the inequality. And here I see I'm once again just demonstrating how tired I am. 45 divided by negative 9 is not negative 9. 45 divided by negative 9 is negative 5. So what I'm looking for is this. All right, and that's why we do these warm-up problems, because as you can see, you have to get your brain turned on. Before it can handle anything complex, it has to handle something easy. So here we go. Now, as far as putting this into the computer, you could put the left side here in Y1, and the right side in Y2. But then you'd have to remember to flip that symbol, and you would have to know that you would need to flip the symbol. So I don't recommend this. I don't recommend the calculator for these inequality problems. I just hate to say this. I recommend that you just do it by hand. All right. So take a look at number 31, and I'm just going to double check a few more settings with Discord and the live stream, and then I'll be able to actually get into your homework issues. So be right back. Okay, so moving on. Now, I want to make sure that I'm taking care of a couple of students who contacted me today for help on the homework. So we'll see if they get online. Just told them that they can have priority if they hopped on. We'll see if they do. Meantime, I got to figure out why I don't have any audio. Yeah, I can hear that. Oh, I know why. Huh. This happened last night too. I understand. I knew it. There's something wrong with it. There we go. I don't know why it was doing that. Okay, now I have to open up Discord. I still can't hear any. All right. Okay, so, well, I'm the only one in the room, so it wouldn't matter anyway. Okay. Okay, good. So, oh, what's up, man? We could do that. We could also just jump back into the homework. I more or less just needed to put something up because I was having trouble getting everything to load. I was trying to get it to load without buffering. Is it okay? All right. And then I tried to load the desktop version of Discord on my other computer, but it yeah. Okay. Oh, I got something cool that we can look at here. Yeah, still from earlier. So if I go to Delta Math, I didn't know I could do this, but I can click on sample student page. Let me show you this. Here we go. So I'll do sample student page from group 4. And then this is a sample of all of your different assignments. I don't have to like necessarily pull up an individual assignment, even though I can. So like, for example, one that kind of the one that I really want to focus on. I want to teach this concept here. What is this idea of continuous growth? Okay, so I'll show an example. Let's see an example. So it says here a quantity with an initial value of 500 decays exponentially at a rate of 8.5% every 6 minutes. What is the value of the quantity after 19 minutes to the nearest hundredth? So last night we did one where we were trying to find the number of minutes. This time they give us the minutes and they want to know the future value. Okay. So this example here with this decaying every 6 minutes has this weird exponent of t to the 6th. It's strange. But if I just grab that first part, what it's basically asking us is it's saying, given a present value or a starting value, what is the future value? See, it literally says, what is the value of the quantity after 19 minutes, which is another way of saying, what is the future value? Okay, so this is All right. Okay, so a quantity with an initial value of 500, and we'll call that the present value. Okay, so future value, there he is. The future value equals the present value or starting value times, open parentheses, 1 plus or minus the rate raised to the power of t divided by p, where t is time and p is the number of periods. Now, honestly, with the exception of these kind of weird problems about decay of like elemental decay, radioactive decay, p is usually 1, and so we usually only just put one number up in that exponent position. So we can actually fill this stuff out. We want to know the future value, and we should say here that this corresponds to the letter y, okay, equals a b to the x, all right? So remember that your equation is y equals a b to the x. Well, we want to know y, okay? We don't know it. We know a equals 500, and we know that b equals 1 minus 0.085. Okay? Yeah. And then x equals t divided by p, which equals t, which we don't know, divided by 6, because it decays every 6 minutes. And this is the part where this is kind of weird. All right. So I'm just going to color code everything where I'm getting this information, so it doesn't blow anybody's head up when they see me start writing it. We have to write b as a decimal. Okay, so 8.5% equals 0.085. Okay, so, I'm going to write this out. So we want to know y. We don't know it. So y equals a, which is 500, open parentheses, 1 minus 0.085, close parentheses, raised to the value of t over 6. Wait a minute. They did tell us t. Hang on. So you remember last time they didn't tell us this. So this time they give us this value t. And the thing, yeah. And so I've got y equals 500, open parentheses, 1 minus 0.085, raised to the value of 19 over 6. So in this case, all I have to do is just stick this in the calculator. There's no need for me to do a logarithm or anything, because I'm just trying to find y. Let me clear this. This is actually much easier. Oh, me too, man. I'm so tired. Trying to. Yeah, you should definitely eat something then. Oh, okay. So let's just put it in the calculator the way it appears. So my guess would it would be 377.4. Because I just stuck that in the calculator, and that's what I got. Oh, it said hundredth? Yeah, you're right. Okay, so 377.40. This is my guess. Okay. I mean, I'll let you look at it. I mean, do you have a do you think we did that right? Yeah, I don't know where everyone is. I mean, it is a Saturday night, right? They're probably doing something else. I mean, there's 4 people watching the stream. It's possible. I guess I'll send out this email. I mean, this message live stream up. Hey, oh, she is? Oh, great. Oh, okay. Jasmine, can you please type the question unique ID that you want me to work on? Because that's what I'm here to do. Definitely was wanting to give you priority. Okay, sure. Oh, I'm just typing a message to remind people that this thing is on tonight, right now. Oh, okay, man. All right, bro. Wait, yeah, mute. Yeah, go mute. Okay. All right. Okay. So let me check and see if there's a unique ID. Hey. Oh, Jasmine. I actually thought it. I thought I was waiting for a different Jasmine. Okay. So hey, but I'm glad you're here. Do you have a unique ID, or are you just kind of chilling out right now? Wait a minute. Wait a minute. Wait a minute. Wait a minute. I can't. I got to reduce the volume of this. Oh, that blew my eardrums out. All right. Oh, I've already got your volume all the way up. Oh wait, now I can hear a little bit. What'd you say? Oh, okay, like when you're doing a problem, beneath your name, it should say unique ID colon, and there should be a 4-digit number. You just tell me whatever number you want me to do. Did you say exponent rules? Level 1. All right. Sounds good. Let me just pull up your account. Okay. Oh, it says you already did it. Okay. Sounds good, though. This is a good one. So wait, let's try. I want to make sure. I want to try this. Let's see if I got it right. 377.40. We never checked. Oh, cool. Look. I just wanted to close the loop with Jonathan. We would have gotten it right. That's cool. Yeah. Okay. So just close that up. All right. So here's Jasmine's problem. Okay. And this is going to be number 275. All right. So 3v to the 8th over 3, open parentheses, v to the 5th raised to the 3rd power. Okay. So the first thing we're going to do is divide these 3's out. So those 2 3's can go away. And now we just have v to the 8th power over v to the 5th power raised to the 3rd power. Now down in the denominator, we need to multiply 3 times 5. That's called the power rule. So that would be x to the a to the b equals x to the a times b. Okay, this is important to remember this power rule. So now we have v to the 8th in the numerator. I love these problems so much. Over v to the 15th. And now we get to invoke another power. I love invoking powers. Okay, so we take, when we have two numbers or two letters that we're dividing by each other, we'll say x to the a over x to the b. Oops, I don't mean to write it that way. I want to write quotient rule. Okay. And that quotient rule says if I have x to the a over x to the b, it's x to the a minus b all over 1. Okay. So applying that quotient rule to this situation, okay, just means subtract the exponents. What? Oh no. Oh no. Okay. That's equal to v to the 8th power minus 15. All right, so you got to do 8 minus 15. What's that? Mm-hmm. -7. All right. And it says, I think it probably says in your problem, use only positive exponents. Oh, whoa. Yeah. So now we're going to invoke a new rule. I think this is what tripping people up. So this is called the negative exponent rule. The fact that there's multiple rules happening here in order. Negative exponent rule. So I'd say that means x to the negative a over 1 equals 1 over x to the positive a. Okay? All right. So now what I'm looking at here is I'm looking at this -7, and I'm going to apply the negative exponent rule, which means that v to the -7 equals 1 over v to the positive 7. Okay? So, Jasmine, I believe, okay, I believe that that is the answer. If it's wrong, I will personally run directly through my front door, and after resigning my position, go back to college and take more math classes so that I can be better at math. Yay! I still want to go back and take more math classes. I want to get I want to take 6 math classes in graduate school. I'll show you why. Here, I'll show y'all why. Okay, so if you want to teach dual credit in Texas, which we want to do, as a teacher, you have to obtain 18 hours. Let's see. There it says. You see it right here. What certifications must a teacher have to teach a course for dual credit? For college level academic courses, okay, so that would be like college algebra, which I want to teach. So you guys could take algebra while you're in high school and get college credit when you're seniors. Requires a master's degree. Okay, well, I've already got a master's degree. Unfortunately, it's not in math. It's in education. So, yeah, I got the wrong one, man. Whoops. Yeah. So I believe I had to have that master's degree anyway. So I got that, but I still don't have the 18 hours in math. Yeah. Now, every single class you take at college or higher is 3 hours per class. Okay. So if you need 18 hours, and you want to know how many classes that is, you just divide it by 3 and you see, oh, I get it. Okay, so there's 6 classes that I need to take. So I'm going to start doing this, all right? But what I'm looking for is Masters in Mathematics Education, Texas online, because I can't go anywhere. And so let's just take a look at the courses that I'd have to pass in order to get this. Oh, wow. $8,200. That sounds fun. Yeah. When I want to see the course list, courses. Here we go. All right. So here's patterns and algebra, right? Seems like that would be relevant. What is this about? Relations, functions, algebraic reasoning, technology, blah, blah, blah. Sounds boring. I want to look at Texas State University. Isn't that in Huntsville or something? Mm-hmm. Okay, so minimum undergraduate requirements are Calculus 1 and Calculus 2. Oh, this sounds terrifying. Okay, so here are my required courses. See, this is the one I want to stay away from. Foundations of Set Theory, Foundations of Real Analysis, Geometric Approach to Abstract Algebra. Let me tell you something. If you want to see me fail everything, make me take these classes, because I hate these classes. This sounds interesting. History of Math, Knots and Surfaces. We'll never need that. So, yeah. Okay. That sounds kind of fun, right? Here's Texas A&M University. See, I really want to take, I think I looked at Stephen F. Austin and that they had one. Here, let's look at the curriculum here. Cultural Foundations of Education. Wait a minute. That's not what I wanted. Oh, this is curriculum and instruction. That's not what I wanted at all. Here's mathematics education. UTSA. Is that San Antonio? It's like, I mean, I think you'd take it online. Anyway, the reason I'm showing you guys this is because, hey, you're in school, and I might be headed back to school as well, but I'll still work. I'll just be taking a. Oh, thank you. Oh, I appreciate that. I was really wanting to see the course list. Here. Let's see if it's there. Courses. Oh, man, these look scary. Yeah. It's just that it's not actually relevant. You know, the one that's relevant here, this looked pretty good. Okay. Where, yeah, this one seemed like it was relevant. Patterns in algebra, probability and statistics, geometry. This is what I would be looking at. I just don't know what this means. Problem solving. I mean, what kind of class is that? What does it mean? I guess we learn to solve problems. Yeah. UTA. It's a good school, I think. Conceptual geometry. Yeah, I'm going to fail this class, even though I'm teaching geometry. I'm sorry. I'm just not good at it, man. I'm just being honest with you. Okay. Yeah. Here's the deal. There are two types of people in math, okay? There's people who like geometry, and there's people who like algebra. What type of people are you? Really? Me too. I am. Let's see. What math type are you? I wonder if there's like a personality test. What type of math subject are you? Okay, here we go. Take it. Okay. Oh, wow. So am I calculus? Am I trigonometry? Or am I algebraic physics? All right. Wow. Okay. So where will we find you in the library? All right. At the coffee bar talking with friends to procrastinate on doing homework. Yeah, that is definitely me. Okay. How would you describe your relationship with your professor? 11:10. They do not know I exist. No. I would say I'd be on a first name basis. I would definitely know my professor. Okay, which fire festival documentary? Okay, I definitely like the Hulu one better. Pick a fictional major if you would study if you could. I would say Greek life science. I don't even know what that means, but that looks fun. Thoughts on math. I am a math major. I dream in quadratic formula. I would say that I'm not as good at it as I want to be. Biggest roommate pet peeve. How about having a roommate? That's my biggest pet peeve. I wouldn't want one. Here, this one. When my food is suddenly our food. Yes, stay away from my food. Okay, my favorite year of high school. Okay, well, I was never a junior or senior. I guess I'd have to say freshman. Yes! What is your favorite type of teacher? One that doesn't care if we skip class, a teacher that shows he really cares about us outside of school. As long as the teacher knows what they're talking about, that's good enough for me. I'm in this category. Yeah, that's me. Pick an in-class snack. Coffee. Don't even need to read the rest. I'm calculus. Yeah! Here, I'll send this to you guys. I'll send this to you guys. You want to take it? Yeah. Okay, let me send this to the general chat. All right. You guys can see that I was telling the truth about procrastinating because we're taking these personality quizzes. We're not doing any work. All right, you guys will have fun with that. Have fun with that for a minute. Oh yeah. Were your parents happy with the calculator in the picture? They were? Good. Oh yeah. I don't think I've ever met them or talked to them. I want to definitely do that sometime. Okay. Yeah. Oh, they came by? Okay. Oh, this is a great one, guys. Because this is definitely on one of y'all's homeworks. Exponential from 2 points. I think it might be on the last one. Let me look. Yeah. Oh yeah, let's do your problem. What's your problem? 296. Okay, let me pull it up. $296. Okay. What if it gets above 1,000? yeah, Doc. Oh wow, dude, this looks really hard. Okay. Bro, this looks wrong. Okay. Here we go. So this is Jonathan. I think the software is giving you harder problems because you keep getting them right. Yeah. Right. Zach Korzik. All right. So this is 0296. John. Probability. Oh, you are your probability. What does it say about you? None. What do you want to do? Oh, okay. Yeah. I mean, these types of quizzes are probably not that accurate. It's like about as accurate as a fortune cookie, right? Yeah. Okay, so this is, y'all can all see now how ridiculous this is. This is Jonathan's problem. It's ridiculous. Well, guess what? Yeah, what's up? Guess what? So all we I think, wait a minute. Wait, I'll tell you what. You know what? These numbers have something in common. They are both perfect. They both have perfect roots. Okay. So this is Jonathan's thing. This is what he's good at. All right. So Jonathan, I want you to actually think about this for a minute. Try to find a number that you could square to get this number here, to get 4096. Or think about it like this, all right? If you want a little head start, start breaking this thing down. This is how I would do it, okay? Here, you work on that, okay? I'm going to go off mic for a second. I think it's going to be 2. But wait, 2 raised to the what power? That's what you got to figure out. Okay? I mean, I really don't know, but I think it's going to be 2 all the way down. Or 6. No, I have no idea. I mean, I want you to, Jonathan, this is actually what you're good at, okay? If you, I'm telling you, you have a special gift, man. I want you to keep factoring down to prime numbers. Here are the prime numbers: 2, 3, 5, 7, 11, 13, 17, 19, 23. You really only need 2, 3, and 5, okay? Remember, 1 is not a prime. So I want you to factor those down to primes and make 2 little trees for me, okay? No, you'll do it. I'm going to let you do it. I don't want to take this away from you. You can do this. Did you have a question, Jet? What was the question? What was it? On Friday, what did we do, Jonathan? I can't remember anymore. Oh, exponentials. We did exponentials. Wait, what period are you? 3? No, 4. You can watch. I think I taught solving exponentials. That's what I did. And the one that was recorded that was good was 5th period. That's where I got everything in. It might be easier for me to just show you now because I can go over everything really quick with you. Yeah, let me finish Jonathan's problem and then I'll do one from 5th period or from 4th period Friday. You got a lot of 2 to the 12th. So 2 to the 12th. So we'll see if we break it down all the way, okay? Let's see. Let me erase all these question marks here. So let's break down 4096, okay? Now, the way you want to do this, Jonathan, is on the left, all these numbers on the left need to be prime numbers. And they have to be in order from the lowest to the highest. So we'll always put 2s until we run out of 2s, and then we'll go to 3, and then we'll go to 5. So what is 2048 divided by 2? 1024. What is 1024 divided by 2? Oh, okay. Yeah. Do you notice this is also memory? 512 kilobits, 1024 kilobits, 2048 kilobits. So memory goes in powers of 2. So now, yeah, 256 is the next one, right? You ever heard like the internet speed the same way, right? 256, 512, 1024. So now what is this? 128. Now you're about to see the next number is the internet connection speed that I had back in the 90s. No, 56. Right? 56. Okay. And then if I divide that by I can divide by 2 and that would be 28. Oh, we don't want to divide by 4. We always want to divide by the smallest prime number. So 2 times 14. And then we're running out of space here, so I make it smaller. 2 times 7, and that's it. Okay. So here's our prime numbers. All right. So let's count the 2s. How many 2s are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 2 to the, this is equal to, hang on a second, we're not done yet. So this is 2 to the 9th. Okay, times 7. Now what we're looking for is a perfect square root, or a perfect root of any kind. Yeah. See, 14 times 2 is 28. So, Jonathan, what I was trying to get at here is, do you see how we factored down to primes and we didn't get to a perfect root? See, we got down and we ended up with 9 2s and 1 7. Well, that's not a perfect root. Let me show you what I mean here, okay? 2 to the 9th times 7 is equal to 4,096. Okay? But we know that these have a common base. Yeah. So what we got to find their common base. Here's what I want to do. Let's do this for 32,768. 2 times, and then let's divide 32,768 by 2. 2 goes into 3 one time. Then 6. Then 3. 8. 4. Okay. So this would be 8, 1, 9, 2. And then 4, 0, 8, 6, if I'm doing this correctly. And then 2, 0, 4, 3. And now I've got to go to 3s because I can't divide by 2 anymore. Did I do this right? Let's see, 7 goes into 12 one time. 57, that doesn't work. 1 plus 2 is 3 plus 7 is 10. Is 127 prime? I don't think so. Let's see. It is prime. Okay. So now we factored this down to primes if we did this correctly. Okay, 2, 2, 2, 2. You're okay, man. Yeah, it's unusual. It's fun. Wait, I don't want to color code that blue. Yeah, but I want to keep the colors the same. So we'll make the 3s orange, and then that 127 we'll make I don't know, green. Okay, so here's what I'm noticing. Here's 1, 2, 3, 4. So both of these share these in common. These first 4 2s they share in common. Okay. So I've got here 2 to the 4th times 3 squared times 127. Okay. Over here, I have 2 to the 9th. Wait, hold on. I could do this. I could do it this way. I could group these first 4 2s as 2 to the 4th. All right. You see that those are common. So I have here 2 to the 4th. Okay. And then I've got 2 times 2 times 2 times 2 times 2 times 2 to the 5th times 7. And this is what I'm interested in. Because we want a common base. I'm interested in the fact that these two numbers are the same. I'm running out of colors here. I'll use yellow. See this 2 to the 4th? Okay, you ready for your mind to be blown? All right. So if I take 2 to the 4th for this 32,000 number, if I take 2 to the 4th power, okay, and wait a minute, I'm thinking about it. What is 2 to the 4th? Let's do that. What is 2 to the 4th? $64, right? So now this is good. Okay, so now I've got 64 times 3 squared times 127. And over here I've got 64 times 2 to the 5th times 7. So again, I've got 64 in common here. Well, let's check it. So 2 times 2 is 4. 4 times 2 is, it's 32. Wait, 2 times 2 is 4. Okay, 4 times 2 is 8. It's 16. Why are we writing 64 like dumbos? It's 2 to the 4th is 16. Okay. Okay. What else? Yeah, it's okay. We're still playing with it. We're still in the fight. Yeah. I agree. And we're trying to Resist the temptation to reach for a calculator here. Okay. Yeah. Well, we're taking the long route here. We're diving deep on this one. Okay. We're really just playing a little game right now. Because there's a way to do this without using the special property, but I wanted to see if we could discover the special property. Wait, where'd our music go? I think it ran out, huh? Do this. Yeah. I agree, man. No, you didn't. No, you didn't. I just said 2 to the 4th is 64, so how do you think I feel? Oh. Well, you're just tired, man. You're just tired. Yeah. Yeah. I mean, by Monday, we're gonna be done with all this, so you guys don't have to freak out about it. That's not how I grade it. I'm not going to grade it based on. I want to see how much you can do. As long as you're trying hard, you're going to be fine. It's a different kind of assignment. Okay. You would not be getting a bad grade for sure. Hmm. To the 5th power. I figured it out. Hmm. All right, you ready to see it, Jonathan? Okay, so 8 to the 5th power equals 32,768. And 8 to the 4th power equals 4096. Okay. So this is the common base is 8. All right. Now, what I was going to have you do, and what we got kind of sidetracked on, was I was going to have you say, well, okay, so 2 is not a perfect. If I divide by 2s, I'm not going to end up with only 2s. All right. But if I divided by 8s, I would end up with only 8s. Here, I want you to see it. Okay, Jonathan? I want you to see this. Somebody needs to mute their YouTube output. So what we're going to do now is divide by 8. Okay, that equals 4,096. All right. If I divide that by 8, I get 512. If I divide that by 8, I get 64. If I divide that by 8, I get 8. See that? Okay, now let's do 4,096. Well, we've already done it, haven't we? 8, 4,090. Oh, I mean, sorry. 8, 512. And then 8, 64. And then 8, 8. Okay, so how many 8s do I have over here on the 32,000 number? 1, 2, 3, 4, 5. Then I've got 1, 2, 3, 4 of them over here. Okay, so let me rewrite the problem now. Now we're ready to move on. Is 1 over... Hang on, I'm going to have to zoom out for just a second so I can see everything. 1 over 8 to the 5th, all raised to the power of negative 5x plus 10 equals 1 over 8 to the 4th, all raised to the power of negative 2x plus 14. Now, let me zoom in on this. Now, Jonathan, how else can I write 1 over 8 to the 5th power? Yes, 8 to the negative 5th power over 1. Okay? I can do the same thing with 1 over 8 to the 4th. So now what I'm going to write is 8 to the negative 5th power raised to the negative 5x plus 10 equals 8 to the negative 4th power, all raised to the negative 2x plus 14. What do you think about that? That's right. That's exactly right. So now what I want to do is I want to use the product rule, multiply these two, and then multiply these two. So let me keep going here. I'm almost done. We're ready to use the magic trick. So now I have 8 raised to the power of negative 5, open parentheses, negative 5x plus 10 equals 8 raised to the power of negative 4 multiplied by negative 2x plus 14. Okay, now the bases are the same, so we can just cancel them. And we can write -5, open parentheses, -5x plus 10 equals -4, open parentheses, -2x plus 14. So now we should go ahead and distribute through. Okay. You still there, Jasmine? Other one, the other Jasmine. You still there? Okay, what's -5 times -5? 25x minus 50 equals 8x. And then what's -4 times 14? It's -56. Okay, so let's keep solving here. How about -8x on both sides? Okay. What's that, 13? Okay, so now I got 13x minus 50 equals -56. Add 50 to both sides. Now 13x equals -56 plus 50. What is that, -6? Divide both sides by 13. So x equals -6 over 13. There's the whole problem. Wow. Yeah, he got a hard problem there. Let's see if it's right. It's not right? Oh, it's 17. Bro. Well, Jonathan said 13. It's okay, bro. I think it does only changes one thing. You still have multiple chances, right? Yeah. Okay, let's try this. Try -6 over 17. All right. So see, we work together to solve that one. Hey, we're helping each other. Okay. Okay, Jasmine. You wanted to learn what we did on Friday, right? Okay, go to your Delta Math page. And I'm going to log in. Okay, hang on a second. Sign in as student, okay? Okay, so I'm going to be under the solving exponentials assignment. Okay, level 1. Oh, perfect. Okay. So we're looking at unique ID number 279. You see that one? All right. So, Jonathan, this would be going for you as well. This one's not going to be quite as ridiculous. I mean, conceptually, the last problem was difficult because we had to find a common base. But we could have done it without finding the common base. And maybe when I realized it was not going to be 2, I probably should have just let you use this just use ln. Because you could always just use ln instead of trying to find the common base. Okay. Okay, Jasmine. So here's your problem, right? They want us to find x. Well, guess what? I found it. There it is. So the very first thing I want to do is divide. What does that sound? Divide both sides by 4 to get rid of that 4 right here. So now I have 2 raised to the x over 4 power. No, don't try to do it. Just leave it as 28 over 4. Well, I mean it has it's 7, right? Okay. When it's easy, go ahead and do it. But if it was going to come out as a decimal, you should just leave it as a fraction. All right. So now we want to get, how do we get this, Jasmine? How do we get this guy to come down here? Do you remember? Yeah, we want to put it in front. Okay, so what I'm going to do is take the natural log of both sides. Okay. So now I have x over 4 times ln of 2 equals 1 times ln of 7. Does that make sense? And that's how this got pulled down in front. And then the 1 also got pulled down in front. And then the exponent disappeared. And we just took the ln of the base. This 2 goes here. And the 7 goes here. Okay? Now, inside of parentheses, just like that. Let me show you your whole problem here. And now we're still trying to find x. Okay? So we're still trying to get at it. What we need to do is we need to divide both sides by the ln of 2 so we can get rid of the ln of 2 and further isolate x. Now I have x over 4 equals the ln of 7 over the ln of 2. Yeah. We're trying to get x by itself. And right now x is being divided by 4 and then x over 4 is being multiplied by ln of step. I need to reverse this division. So right now x is being divided by 4. I need to reverse the division. How do I do that? How do I get rid of the 4 in the denominator there? Yeah, multiply both sides by 4 over 1. Just multiply by the reciprocal. Okay. So cancel, cancel. Now x is by itself. X equals 4 ln of 7. over ln of 2. That's the answer. Okay, but we have to actually compute it and round it to the nearest hundredth. So let me move this over here. And we're just going to plug it into the calculator. So first thing I'm going to do is hit this alpha y equals enter. Okay, and then I'm going to type 4. And then I'll hit ln of 7 over ln of 2 and close the parentheses. And here's the calculator input. Okay, now hit enter. Here's the answer. Okay. Now your problem asks you to round it to the nearest hundredth. So here's the hundredths place, and I need to look at the place next to it. And if it's 5 or bigger, I need to round that pink up. Okay. Yeah, I'm sorry. It's going to be here. This is going to be 3. So my final answer is 11. Whoa. My final answer is 11.23. Was it right? All right. All right. That's what we did on Friday. We just did a bunch of problems like that. Now, the next problem I want you to do, Jasmine, is under solving exponentials. I want you to go down, skip all those skills, and go down to exponential functions, basic solving. Okay? Now you got a word problem, right? Okay, so do you want to take a break and then come back and work on this? I feel like Jonathan needs a break for sure. All right, guys, let's take a little break and then we'll come back and work on this word problem. I'm going to go off mic for like 5-7 minutes. See you guys in a bit. And start working again. We'll do Jasmine's word problem, and then I think we might have another student with a specific problem, okay? Still be about 5 minutes, okay? What was that? I don't know. Hello? Hey, I'm going to go black on the screen for a second so I can pull up Jasmine's problem. I don't want anyone to see. Oh, hey. It's Jay. Oh, there was a parade tonight? What was it about? Mardi Gras? Oh, that's now? I didn't know that was now. Cool. What'd you get to eat? Tacos from the new taco place? Juicy. What'd you eat? Taco with cheese. I like that place, but it's pretty expensive. Okay, I'm showing the screen again. Give me a second. It should be live back now. Okay, so now we're doing this problem here, and then we're going to help another student. So this is Jasmine's problem, number 281. Okay. So if anyone else is on this that hasn't done this particular type of problem yet, this is the under solving exponentials assignment, exponential functions, basic solving, these word problems. Okay. These are actually kind of fun. They are. Yeah. Depends on your definition. Okay. So it says here we start with $3,400. Okay. And it's going to be growing at 5.75% every year. Okay, so the rate of growth is going to be 5.75%. And it says to the nearest year, how long will it take for the account to reach $15,600? Oh boy. We have a lot of money. Yeah. Well, we're going to let the calculator do all the hard work for us. So remember, I have my basic exponential function is y equals a b to the x. Now over here, we're going to identify what these are. So y is the future value. What do you think that would be? What number would that be? 15,600. And a would be the present value or the starting value. And that would be 3,400. Okay. And then we need to talk about B. B is either 1 plus the rate or 1 minus the rate, depending on whether it's growing or shrinking. Is it growing or shrinking? It's growing, so we'll use 1 plus the rate. Now, what is the rate? And can you express that as a decimal? 5.75% as a decimal is 0.0575. So that's 1 plus 0.0575, and that equals 1.0575. Okay? So all we're going to do now is go back and plug those numbers in. So we have 15,600 equals 3,400. Somebody needs to either get off mic or mute the background noise because I hear a bunch of stuff in the background of somebody's mic. Okay. So it's 3,400 times 1.0575 raised to the power of x, which we don't know. And we should identify x equals time in years. All right. And that's what we want to find. Okay. So we don't know what x is, and that's what we're trying to figure out. So now I'm going to divide both sides of the equation by something. What should I divide it by? Well, right now, x is being exponentiated from 1.0575, and that's being multiplied by 3,400. So I want to undo this particular multiplication by 3,400. So I'll divide both sides by 3,400. Okay. And we're not actually going to do that division on the left. We're just going to leave it. We'll let the calculator do all the work for us. Yep. So 3,400. Yeah. So now I have 1.0575 raised to the x power. So here's where you're going to use your natural logarithm, okay? To pull that that x down in front. That's what we want to pull this x down in front. We're going to move it. Yeah, this is called the power rule for natural logarithms. Okay, so what I'm going to do is take the ln on the left of 15,600 over 3,400 equals x, because now x gets to come down in front, times the ln of 1.0575. Now I just have one more step. I need to get rid of this multiplication here. I need to get rid of everything that's next to the x. How do I do that? Yep. By the ln of 1.0575. Mm-hmm. All right. Cancel, cancel. Can you guys believe that you're able to do problems like this? This is really hard stuff. That's crazy, right? I'm really proud of you guys. Arigato gozaimasu. All right. So this is what I want to put in the calculator. So what we're going to do is hit alpha y equals enter. And then ln alpha y equals enter. 15,600 over 3,400. Okay. And then in the denominator, I'll have ln of 1.0575. Okay. Now let's make sure that it looks correct. This looks exactly like this. All right. So let's hit enter. Boom. And let's grab our data output. And so it says to the nearest tenth of a year, I think. To the nearest year. Ooh, to the nearest year. Okay. So what is this to the nearest whole number? We want to round this to the nearest whole number. Yep. So I want to round to the nearest whole number. So I'm going to look at that 7. And then I'm going to take a look at this 2 right here. Do I need to round up on the 7 or just leave it? You just leave it, right? So the answer is x is approximately equal to 27 years. Oh, okay. But that's what you thought it was? So you were right. Oh, no. Don't be scared. Remember, I'm the guy that said 2 to the 4th was 64. Wait. Well, yeah, you were the guy that divided 5 something by... What, Jasmine? Oh, yeah. Oh, I don't... yeah, but I don't want people... I don't want people to be afraid. That's okay. So let's see if it's 27. Look at all that work. Wow. Yay! Let's use our cool font that we don't use enough and say, yay. Oh, wait, I think this has bad words. Hang on. Da 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 da. Okay. There. I know this 1 hour set here that we keep playing over and over. The reason I do it is because I know it has no bad words. You don't hear music. Wait. Oh, no, you're right. It's not playing. Oh, man. Okay, hang on a second. Wait a minute here. Let me check OBS. So, hang on a second. Let me check this. What?
He was at the Starship.
Now do you hear it?
Yeah, I hear it. Oh, what the? Okay, there we go. As soon as you said now you hear it, it's
Is it loud? Is it too loud or is it okay?
It's alright.
Should I lower the volume? It's fine? Okay. Let me check and see if that other student gave me a problem to work.
I'm back on now.
Oh, okay. Hey, which problem would you like me to work? You get to pick anything you want.
The same one as the other Jasmine.
Okay. But just your version of the problem? Okay. I love it. All right, let's do it. Give me just a second. Yeah. Okay, so everybody's going to see black for a second while I go check on that other, in the other Jasmine account. Can you guys confirm you see black?
I see black.
All right, cool. So glad I can do that because otherwise I wouldn't be able to do this at all. So I'm excited to let you guys know that we as a class made a fairly sizable financial contribution to Zach at Delta Math yesterday. So hopefully he'll be giving us our feature where I can give all of you the same problems soon. Yeah.
It'll help everybody a lot.
Yeah. Jasmine, how are you doing?
Who, me?
Yeah. Who, me?
Okay, it's like this. I'm like,
Yeah. I'm trying to think of a different way to say your name. Like Jasmine.
the second one.
The second. I'll call you. I don't want to call you the second one. Y'all are both first in my eyes. Yeah. What's up? Call you what? Jasmine the noob. The noob. Okay. Okay. All right. We should. I was thinking about that for live, like for our class live streams, just like getting everyone to come up with a nickname, so I could say like and let's say hang on. Wait, Jonathan changed his name. What was his other name? Oh, I forgot. Crispy Toast. Yeah, so I could say like, all right, Crispy Toast, tell me the square root of 64. Yeah. So anyway, here's what's that unique ID, Jasmine? 2 0335. I'm sorry. There's no way to do this without like
two people with similar
Jasmine. Huh?
Your name will be Jasmine. My name will be Jasmine in the news. Okay.
Okay.
Oh, this is exciting. So we're buying a new car. Yay.
Is it what kind of car is it?
It's a Lambo.
Oh, Dang.
Now it's only $22,000, so it probably has no doors and no engine and no wheels. What kind of car could you buy for $22,000? Like a Toyota Corolla?
Yeah.
So funny.
Okay, hang on a second. Here comes the screen.
Oh yeah, it's black right now.
Okay. I can't believe there was no audio for y'all. No music. And I'm sitting here stressing about the words. No one can hear anything.
Okay, it's really, if somebody named has the first name of Jonathan, then call me Crispy Toast or
Crispy Toast. Okay. Crispy Toast, Jasmine the Noob. Yeah.
Yeah,
no, right?
let's go.
Well, you don't have to say Crispy Toast because like I'm the only Jonathan here right now.
Yeah.
But there's like 400 Jonathan. Yes.
Somebody said
Wait, I
that.
got a different problem than that one.
Oh.
Good. I'm talking to my sister.
Hang on a sec.
Good.
Hang on 1 second. Hello, Miss Tom. Hello, Faye. I can't say last names. Tell her I said hi, okay?
Okay.
Hey, almost screwed up.
Miss Morales said hey.
Yeah, no, I know the screen's black. I want to make sure I'm looking at the correct problem for Jasmine too.
Oh.
Not number 2, just Jasmine 2. Okay. So you want me to do 0335. Okay.
Yes.
Okay, let's see here. Wow, you did a lot of work. Okay. I see you did a lot of these. Good job. Okay, so the question that I pasted into the view was from solving exponential functions, basic solving. But let me find... Oh, I see what you want me to do. Okay, good. I can do this one. All right. So this is a different one. But that one that I did... Hang on, let me get the correct number for it. 0349. Give me just a second. Pardon me. Okay, so we probably need to do that one, but we'll do this one first. 0335. And I'll show the screen in just a second, guys. Hold on. Coming back up in 3, 2, 1. Live. Hey, who's excited about Stranger Things Season 4?
Me.
Yeah, I'm excited.
Wait, what is Stranger Things?
Shh. Oh my god.
I'm just playing around. It's on Netflix. It's your favorite series.
It is my favorite series. Let's see when the release date is. Sometime in 2020. What's Stranger Things? Bruh. Wait, here. This is my man Freddy, bruh. All right. So, Jasmine 2. I gotta wait. Do you have a preferred nickname? What would be like your cool nickname that you would want to use here?
Most people call me Jazz.
Jazz. Okay, that'll work. So Jasmine the Noob and Jazz. I like that. Okay.
Yeah.
So Jasmine, Jazz. I'll get it. I'll figure it out. So here we go. Right now, you got 27 times 10 to the 4x equals 24. Okay.
Yes, sir.
Now, I just want you for a moment over here in side work. Think about it like this. 27x equals 24. What would you do if you wanted to get x by itself?
Multiplied by 24?
No. You want x by itself. Right now, it's being multiplied by 27. What would you do?
Oh, you would divide, right?
Yeah, you would divide. So it's the same thing over here. You would just divide both sides by the thing that's in front of the 10 to the 4th power, 10 to the 4x, which would be 27. So just divide both sides by 27. Cancel, cancel.
Cancel.
And then I've got 10 to the 4x power equals, and then don't try to reduce this or anything. We just have 24 over 27.
Okay.
And now we're going to use our special magic trick called the natural logarithm. And what that's going to do, Jazz, is it's going to pull this 4x down and sit it in front. It's going to take it out of the exponent position. That's our special magic trick that we learned this week. So what I'm going to do is put both sides in parentheses like this, and I'm going to take the natural logarithm of both sides. It looks like something new and scary, but it's actually a really cool thing if you ever want to get something out of the exponent position. Okay?
Okay.
So now I have 4x, because now it gets to sit up front, times the ln of 10. See? So this 10 stays here, and this 4x is now sitting up front. And that's all that did. But that was really useful because before I would never have been able to figure out what x is, and now I think I might. Now this is equal to the ln of 24 over 27, which we don't care. We're going to put that in the calculator. All right?
Okay.
Now, I still want to get 4x. I want to get 4x by itself. Right now, 4x is being multiplied by the ln of 10. So how would I get rid of the ln of 10?
Divide?
Mm-hmm. So Jazz is correct. We're going to divide both sides by the ln of 10. All right. And I get to cancel those out. And now we have 4x by itself equals, and the ln of 24 over 27 divided by the ln of 10. Okay? Which we don't, those are numbers. We just don't care what they are. And now all I want to do is get the x by itself. Let's let her catch up.
Yeah, I'm waiting for the screen to catch up.
Oh, you are? Okay.
Mm-hmm. Okay, it did.
So what would you like me to do now?
So that's all it was?
No, we got to do one more step. Get rid of the 4.
Would you divide since it's multiplying by the x?
Yep. Now, because we have a fraction on the other side, instead of just straight up dividing with a fraction bar, what we're going to do is we're going to put both sides in parentheses and multiply by 1 over 4, which is the same thing as dividing by 4. But in this form, it will make us avoid the pitfall of not knowing what to do with that 4 on the right side. Okay?
Okay.
So on the left side, these 4's cancel out. And I now have x by itself equal to ln of 24 over 27, all divided by 4 times the ln of 10.
I gotta wait, the screen is buffering.
Oh, so, okay.
I got it.
Okay. So how do you feel about this? This is just a number. It's just a number. Now, so all we're going to do now is actually evaluate this and get an approximation, okay? So I'm going to go into my TI graphing calculator and I'm going to hit alpha y equals enter. And then in that numerator, I'm going to put this ln of 24 over 27. So I'll hit the ln key and then I'll actually need to hit alpha y equals enter again. And I'll put 24 over 27. And then in the denominator, I'm going to type 4 ln of 10. 4 ln of 10. Okay, close those parentheses. Now, does this look like what we wrote? I'll let it catch up for you. All right. So we're ready to press the enter key. Is everyone just looking at a red enter key right now? All right. So there it is.
Why is it red, by the way? Not just playing.
Okay, so let's look at the problem. Did it tell you to round to the nearest number or something? Jazz? 10th? 100th. Okay, 100th. All right, so here we are. So we're looking at the 100th place, and then we're going to look at the number to the right of it. Do I need to round up or just leave it? Well, yeah. This is the 100th place. Okay, so I look at the 1000th place, and if it's 5 or bigger, I have to round the 100th place up. So we just leave it. So we can say x is approximately equal to negative 0.01. So that's what I think the answer is. What? Oh, no. You're just going to type the number. You're just going to type negative 0.01. And let's see if it's right for Jazz. All right. Now, you know what? Here's what I'm happy about, guys. And maybe I didn't do a good job of saying this in class because I have to keep. I mean, I don't mean to say that like I have to keep the pressure on, but I have to make it seem like I want the best from you. So I want to make my expectations very high in class. But in reality, I just want to expose you to this math. You're not expected to master this concept, okay? I want you to play with it. I want you all to get exposure to it because usually what teachers do when they get to this part of the chapter or this part of this Algebra 1 is they just skip all of this, okay? They just skip it because they say, oh, kids, it's too hard. The kids won't get it. And my view on the issue is, yeah, they're not going to master the concept completely, but here's the way I look at it. Every single one of you, this is something our principal did. Every single one of you will take Algebra 2, right? When you're juniors or seniors, depending on your path, okay? So you're going to take Algebra 2. Guess what you're going to be doing in Algebra 2? This. So I think that the way I'm looking at this is I'm placing a deposit into the bank account right now. And I think when you guys are all older and Mr. Morelli's just an old man that used to be your teacher like 2 years ago, you're going to get to this part in the book and you're going to say, oh, you know what? We did this. You know, that's my hope. And so I don't know about that, but I think you'll say like, oh, you know, I think you'll have a foundation that's there that you didn't even know was there. I think you're building a little bit of a foundation right now. And so I'll tell you, here's the good news, guys. None of this is going to be on the STAR test. As in none of it. None of this logarithm stuff is going to be on the STAR test. Before I showed you the part of exponential functions that is easy, I wanted to show you the part that's not so easy. So we get that out of the way, and then the rest of it is super easy. So You're not going to be given a test on this. I just wanted you to play with it.
Were we experimenting something?
Yes, that's exactly what you were doing. You're experimenting.
What are you guinea pig?
Well, oh, no. Oh, so you were experimenting. I wasn't experimenting. So last year I did the same thing, but I chose a different topic to dive deep on. And the topic I chose to dive deep on last year was quadratics. And we focused, before the STAR test, we focused heavily on completing the square, which was like paper and pencil solving of quadratics. Like we spent a ton of time on that. And that was making the kids think they couldn't do math and everything. And now they're in geometry. And guess what they're doing? They're doing advanced quadratic factoring by completing the square. And so they're like, oh yeah, I remember this from last year. And so that's the only purpose. So I'm not going to test you on it. And the way I'm grading the homework, just so you guys understand, as long as you're trying it, okay, you're going to make 100. But what I was frustrated with is the people that were not even logging in. Okay. Not attending the live streams, not coming in for tutorials, not coming to the PlayStations, not reading the book, just not doing anything. That was what was bothering me. And so, like, everybody that's on this chat is going to make 100, like 3 straight back-to-back 100s, because you're spending all this time working on this. And that's all I wanted. That's all. I just wanted you to try. Yeah.
I remember like you made a lot of videos. However, you normally don't go live.
So, yeah, well, so like I can't remember the last time I made a regular video. I need to get back into that because those get a lot of views, but I'm really not trying to grow this channel. You know, I'm trying to find a way to make it useful. Right. Yeah. So here's what I want to do with your time for whatever time remains that you guys are going to be on this thing with me. Jonathan and Jasmine the noob. Y'all were at the PlayStation this morning, right?
Yep.
Now, Jazz. She's still there? Okay, let's make her feel a little bit more comfortable. Was any of this on the STAR test that we did? Was any of this natural logarithm stuff on that any of those 29 questions that we did? No. We did not do any logarithms. Here, I'll show you. Here's what we did. Here. Let's see. Okay. We'll wait for it to catch up. Let me show you an example of an exponential function. Here's one. Let's look at number 4. Okay. Jazz, let's wait for this to buffer up and get. Do you see this, Jazz?
I do. Yes, sir.
All right. Now, this is an exponential function question from the STAR test. Okay? So, what I'm going to do now is I'm going to pull up Desmos test mode. See this? I'm going to plug this into Desmos test mode. Y equals 8, open parentheses, 0.25, close parentheses, raised to the x. I'm going to go over here and click this. This is the y-intercept at 0, 8. Do you see that? Or wait, it's not there yet. Can you see that?
I do.
Okay. So let's look at the answer choices. The coordinates of the x-intercept are 0.25, 0. Well, that's not true. The coordinates of the y-intercept are 0, 8. Is that true?
Yes.
That was it. That is not hard, right?
It's not hard at all.
No. So I just want to let's do another couple of exponential type questions from the STAR test. This one was hard. Let's leave that there for now. Let's see where that another exponential came from. What'd you guys think of this STAR test this morning? Was it pretty easy or was it kind of hard?
It was easy, but then I had a little bit of a hard time. Just a little bit.
Well, guess what? We have until May, so we're going to be fine. Because that's this. Well, now that we've finished these exponentials, we're only going to be practicing the STAR test until May. And some of you may have talked to your friends from the sophomore class. I changed the whole classroom environment when we start preparing for the STAR test. And remember the buzzers?
Oh, yeah.
Yeah, we're going to get those buzzers back out. We're going to play games like Plickers. We're going to play Quizlet.
Oh, yeah,
Quizlet. Kahoot. We're going to play games, okay? And we're just going to practice STAR questions. That's it. So from now until May 5th, everything's going to be centered around teaching you what you need to know for the STAR test. And the reason I held off until now to do that was because once we start preparing for the STAR test, there's no turning back. Like, we can't prepare for the STAR test a little bit and then go learn more math. You know, like, once we start doing the STAR test, we need to keep preparing for it. So let me just show this problem here. This is another exponential functions problem. All right. So let's read this together. There are 1,024 players in a tennis tournament. In each round, half the players are eliminated. Which function can be used to find the number of players remaining at the end of X rounds? Jazz. Let's look at this problem. So the starting value is 1,024. Every round, half the players are eliminated. Okay? So which answer choice looks like we're going to be getting half of the players?
I think it's B.
That's correct. So Jazz and Jasmine the Noob and Crispy Toast, okay? And Jay, if he's still listening. This is as hard as it gets. And so I hope I over-prepared you, you know? Yeah. So here, let's do this one. Well, no, let's not do that one. Let's go down to a new one that maybe my folks from this morning didn't see. Oh, I love this one. So this is a STAR question. All right. Let me zoom in on this. Let's look at this. Let's look at this graph. What X value is that line passing through? So the equation of the line is X equals 6, and the slope is undefined because all vertical slopes are undefined.
Oh, yeah.
Remember that?
Yeah.
So let's let Jazz pick, okay? Because I want to give her some confidence here. What's the answer to this question?
It's J.
That's correct.
For Jazz.
Ooh, this looks really hard, doesn't it? Number 33. Guys, you can do this. You can do this. I want everyone to look at this problem. Wait, it's probably, is it too small to read? All right. And I want Jazz to answer the question. and I'm going to give a help. I'm going to give a lifeline. So C of X equals 495,000. We see that that's the same in every single problem. Okay. And then it's going to be open parentheses 1 plus the rate as a decimal. Okay. Raised to the power of X.
What then? It's either A or C, but I think it's A.
Guess what, Jazz? You're right. It's A.
Bravo.
You didn't even need to do any math. And that was as hard as now. In Delta, we actually solve for X. But they don't ask you to solve for X on the STAR test. If you had to solve for X, you would need to use the logarithms and stuff. But you don't have to do that on the STAR test. Here, let's do number 34 together. This is a good problem. What is the solution to 34x plus 95 equals 3, open parentheses, 14x plus 9? You guys tell me, do you want to use Delta? Oh, sorry. Do you want to use Desmos or the TI? TI. So I'm going to pull up TI. And Jazz, you can do this. All right. Do you have a TI with you? Or are you?
Well, I mean, I was watching the video.
Okay, you're just watching the video. All right, here we go. So you all know how to do this already from 8th grade. We're going to put the left side in Y1. And the right side in Y2. And then what do I hit? What do I do? Second graph? Is that what you said? Second graph. Okay, let's look at second graph. What are we looking for? We're looking where the y's are the same. Okay? Where are they the same? Can I make a suggestion? You okay? Can I make a suggestion, guys? Instead of using second graph, let me show you this way. Hit second, then trace, then hit 5. Okay. We need to zoom out until we can see the intersection. So zoom 3. And zoom 3 again. Okay. And now I'm going to hit second, trace 5, enter, enter, enter. Look right here. What is X? That's it. That's the answer. Now, the reason you had to use second trace 5 instead of second graph is because X was a decimal. Okay, when you look at second graph, it's only going to show you X's whole numbers. So you would never be able to find it in that second graph list. Now, I want to show you in Desmos, and I want you to tell me if you like Desmos better. Okay? All right, so we have to write y equals the left side, because in the TI calculator, it already gives you the y equals part, but in Desmos, you have to type it y equals 34x plus 95, and then y equals 3, open parentheses, 14x plus 9. Okay, now what we're going to do here is go up and see where these things intersect. Let me zoom in on it. Just keep scrolling. They're getting closer and closer together. I think I see it. It's coming right somewhere in here. Right there. You see that? So there's 8.5 again. Okay. So two different ways to do it. Both are fine. All right. I think for this particular problem, TI was easier. Yeah. Here. Let's see what you guys think about this.
Thank you for your help.
Oh, you're welcome. See you later. Have a good night.
Really? Really, Mr.
What's the slope of G? No. It's 1/3. 1/3. Right? Here, let me show you how I figured that out. We rise 1, run 3. 1, 3. Okay. Now for this F1, you see it's rise 1, run 1, rise 1, run 1. So it's 1, 1. The other one is G is 1/3. Okay. So let's look at the answer choices. What do you think it is? Correct. Correct.
Is it because you have the word noob in your name and noobs and bots are like the same? What the? Mr. Riley, stop it.
What?
You keep making the screen black over and over and over.
Oh, it is going black on you?
Yeah.
Oh, I'm not making it black. I don't know why it's glitching out like that. Oh, I'm sorry. Is it okay now? All right. Sorry about that.
Honestly, we gotta multiply these together, huh?
Yeah. No, wait. I wouldn't say you need to do that. You could just put the given expression into Y1 and start testing your answer choices in Y2, or you could put them in Desmos. So Desmos might be easier here. So let me show this. Okay, so I'm going to have to use X where I see an H. So I'll write Y equals, open parentheses, X squared plus 9X minus 1, close parentheses, open parentheses, negative 4X plus 3. Okay, and then I'll try the first one. Y for F. Y equals negative. Wait, well, first I want to make sure I can see it. I got to zoom out from that other problem. Whoa. I zoomed out way too far. Sorry about that. Hang on a second. There. Okay. Okay, here we go. See that? Curve. So now I'm going to just start typing in the answer choices. Y equals negative 4 x cubed minus 33x squared minus 3. Is that correct?
No.
No. So let's look at G. 4x cubed
Yeah.
plus 39x squared minus 23x minus 3. Is that the same?
Completely wrong. Nope.
It's completely wrong, huh? Hmm.
It is pointing below. Well,
So now we'll look at letter choice H, okay? Negative 4x cubed minus 39x squared.
I got a good feeling, Mr. Morelli.
Yeah, me too, man. Plus 23x plus 3. Oh, whoa, whoa, whoa.
Yeah. Actually, what if it's trolling?
Nope.
Wait a minute. Let's see if I typed it correctly.
Wait.
Yeah, I typed it correctly.
It's correct. Yeah. That's
Why aren't those the same? Let me look at the first one again. Oh, this will scare me if it's not going to do it. Well, hang on. Let me try this first one again. Negative 4x cubed minus 33x plus... Oh, I think I did. I know what I did wrong. Minus 33x squared. I think I wasn't leaving that out. Plus 31x minus 3. Oh, we got it right with F, and I just didn't put the squared term. I'm sorry. Fail. I just forgot that 2. Okay, so that was easy. Anyway, guys, I feel like we've done good work tonight. What do you guys think? I want everyone to have a good evening. And Jonathan and Jasmine the noob. Okay? And you guys have done more than enough work. Okay? I want you to take tomorrow off. Okay, this is your teacher telling you that I don't want you to try to finish all those problems, okay? You've done enough. Okay? Just get some rest. All right? And I don't know if I'll do a live stream tomorrow. I might, but it would be like a lesson planning live stream. But you guys just rest. Okay? You guys have done above and beyond. Okay? I'm proud, really proud of both of you. So you guys have a good night, and thank you for being such dedicated students. Okay? Let's see here. All right.
Oh, yeah, since
What?
since I'm not in your fourth period anymore, I'm guessing Jack, the only person that watches your videos in that period.
I have no idea. I have no idea. I don't want to talk about any specific period. Let me just show the screen again. Okay, let's check on our stats here for this live stream before we close out. So we've had 39 playbacks. Average watch time of 16 minutes. And 4 concurrent viewers. That's great. You know, for a Saturday night. So you guys have a great evening, and thanks again. I'll end the stream here, okay? Good night, everybody. Bye.